Hello everyone. Today we are going to be discussing the first five problems of the contest Codeforces round 902. It was a did one and different contest. In the first problem, what it says, like you can read out the problem statement by pausing it and then read it. Uh, in the nutshell, the problem says that there were n games, or basically, maybe let me just read it out. So there are n teams, and for every team, it match up once. Each pair of teams match up once, and then after all the games, what we say is that the efficiency of the team is equal to the total number of goals that team scored minus the total number of games, the total number of goals the other team scored. So it is like there are n teams which would play with each other. Maybe there can be many teams which would play with each other and only with each other only. So every team would score some goals, and the opponent team would also score some goals. For every team, we define its efficiency as the number of goals it scored. So, goals scored by that team minus the goals scored by all the opponent teams. Goals scored by opponent teams. Right. This is what the problem tells us. And now, among the n teams, for n minus 1 teams, we are being given what are their efficiencies. So we know the efficiencies of those teams. And for one of those teams, we don't know about its efficiency. Let's call the team as nth team. Right. Now the thing which you had to notice was that if all the games are being played among these teams only, so at the end of the day, the total scores, like total goals, would be like same for every team. And basically, what will happen is every team would have scored some goals, which is positive, and the opponent team would have scored some goals against them. And if you add out all of them together, you will get zero at the end. So this is what you had to observe, and this is something that is pretty standard. So the sum of efficiencies of all teams, efficiency, I don't know what's this spelling. Sum of efficiency of all the teams should be zero. You know about n minus one teams, so like the efficiency of the nth team would be just the negative of the sum of all the efficiencies of other teams. So we can do it like this. Just calculate the sum of efficiencies of all the n minus one teams, and then say that the last team must have its negative as its efficiency. Okay, so is this problem clear? Does anybody have any
Yeah,
query?
hello.
Yes.
How did you reach to the conclusion that summation of efficiency is zero? Is it standard? Uh, how did you reach here? Sum of the efficiency is zero for all the teams,
Okay.
and
So
the answer will be negative of the efficiency.
okay. So what you can say is that for team one, it would have scored some goals, and for its like for this team, some opponents would have scored some goals, right?
Mhm.
And the same for team two and the same for team three. At the end of the day, the total goals should be equal to the total goals by the opponents because the total goals which every team scored should be equal to the total number of goals which the opponent scored for them against them. because every goal has been scored by these teams only, by only these n teams. There is no external other team which scored any goal and it would make any difference.
Yeah.
You know?
Okay.
So the efficiency for all the teams combined should be the total goals scored by all the teams and minus the number of goals scored against them. But we know that both of these numbers should be equal, so it should be zero, right?
Okay.
You know,
So,
and you know that for teams like from team one to n minus one, it's efficiency. Like the difference of them for individually, but you
mhm,
don't know for the last one. You know? But
okay.
you know that if you add this number, whatever efficiency it has, with the efficiency of the n minus one numbers, it should come out to be zero. So efficiency of team n minus plus efficiency of team from 1 to n minus 1 should be 0.
Equal to zero.
है ना? So you can say that if you
Uh-huh.
just take this thing there, it would just get
Uh,
negative.
yeah, yeah. So it will
That's
be
how,
negative of that value.
that's how we do it. So this is kind of a logical proof. But generally, whenever you see something like this, you should be getting this intuition that since every team is there itself, at the end you will be having the sum to be 0, and you don't need to prove it like this every time.
Okay, okay.
So this is how we code it. You could just take all the inputs, then you could find the sum of all the efficiencies, and the output would be just the negative of the sum. Right.
Mhm. Yes, yes.
Yeah. So let's move on to the next problem. The next problem, uh, like you can read it out the statement, but what we have to do in the problem is something like this: that there is someone. Let's say we have name Park. There is someone with name Park, and there are n people. I think it was something like it wants to give it some information or whatever the story said. It wants to pass on some information on maybe something like that. Um, Important announcement, yeah, some announcement, and it would have a cost fee if Park directly tells that guy, those people, and for every guy, like for every person, that person can tell to other guys also. Any person can tell to any other guy with a cost of BI, like for the ith person, the cost is BI, ith person, the cost is BI, and that guy can tell to AI number of people. This the problem says this, and Park can control which people pass on information to which people, pass on information to which people. So this is something which Park can control. And what we have to find is what will be the minimum cost. This P, this BI, this AI are the cost, and we have to find the minimum cost. Okay, fine. Is the problem clear? Please confirm at once. Okay.
Can you repeat what is AI and BI? Cost.
AI is the number of people uh, to whom this ith guy can tell the information. So if AI is 3, it means that the ith person can tell about the information to only at most 3 people. Like it
Okay.
can tell to either 0 people, 1 people, 2 people, or 3, but no more than 3 people. And this BI is the cost for telling to any other time. It
Okay.
would
Okay.
be on every time there is some announcement by this guy. Okay. So It was a greedy problem. Like my solution was greedy. What I said was that Park needs to tell it to at least one guy. Park needs to tell to at least one guy, है ना? And at most m guys, at most n people. Yeah, the greed here is that if Park has to tell to at least one guy, and like let's say there are two people, one guy with the BI equal to 5 and the other guy with BI equal to 10. Now, no matter what is the value of AI, now no matter what is the value of AI, it is always beneficial to tell the information to this guy first. And as long as uh, like as Park can control which guy tells to which guy, so he will always choose the guy with the smallest BI to pass on the information to some other people, to some other people having the smallest BI. Like the people who will get the information first will always be having the smallest BI. It will always have the smallest answer. So this was the greed. And I think that just looking at the greed should be self-intuitive now, that it would be better to tell the people with a smaller BI because they would be able to help us in some way. Whereas if you choose a guy with a higher BI, it would never be better than choosing a guy with a smaller BI. Even if the AI is equal to 0, even in that case, choosing this guy first is having no disadvantage, as you have
If
to choose it.
in the first case BI 5 and AI is 10 and other BI another case BI is 10 and AI is 0.
Like whatever is the case, even in this case, you still have this better. Like this case is even easier for you to see ki you should always choose this guy first. And even in the worst case, what you say is that if AI is 0 for the guy with a smaller BI, which means that if you pass on information to this guy, he cannot pass it to anybody else. It is still having no disadvantage of telling him first, because at some point of time you still need to pass on the information to this guy. So
Yeah.
what we can say is that sort the people in terms of their BI to be in ascending order. And now always pick up the guy with the smallest BI. It would be very easy once you sort it. If you don't sort it, it is still possible, but it won't be efficient there. And always pick the guy with smaller BI. Pick the guy with smaller BI. And now who will be the person to tell this information to this guy? It would also be the cheapest option we have, whether it is choosing just Path, which has a P, or just choosing a BI of the people which we have already chosen. We will decide it on our own. So for the implementation purpose, like this much is the logic's only this much. For the implementation purpose, what I did was to just create a map. Initially, I decided that I can have the cost of P, and like I just said that as I have AI and BI for every guy, I just said that let's say for Park the AI is n plus 5 because Park has no limit. So n plus 5, even if you take n, it is sufficient. And the BI is just P, the cost of telling to any other guy if the person who is passing the information is Park. And he can tell to as many people as he wants. Uh, Vector of pair, okay, so used vector of pair and then got messed up. I would say that using a map is like very chill. Just created a map and set for Park it is in plus 5. You can take an also. Just to be on the safer side, I don't know why I didn't take plus 5. Uh, like you can take n, it's fine. And then I just went for every guy. I just went for every guy and said that, hey, I will just find the min cost I have right now. Let's say I'm in equal to in the map to find the smallest key, but you can say something like this mp dot begin first. Like this is something you would have studied in STL, or if you studied about maps a little bit, this is the way you can find the smallest key, or maybe by dereferencing it and then accessing first. And then I will definitely, since I've already sorted, it would be the first guy, the guy I should be chosen. So I will say that now I have MP of AI. Basically, in the array which I created was such that AI 0 is the cost. Basically, it is the BI, and AI 1 is the count to which how many people it can pass the information. And basically, you can implement it in any way you want. This is just my implementation, and I did some a few more lines, and then at the end I just printed the answer. So this is how my implementation looks like. First of all, I took the inputs till here. Here I have been storing the cost in AI1 and the count in AI0, so that I don't have to write a custom sort, just normal sort will work. And I initialized map of the map of p with n plus 5 and a long answer. Since the answer can be in long, I guess, and it can also be long, the count of people. I didn't really spend much time in thinking, so that I just took a long directly. And after sorting, I went for every guy. Since they're sorted, the lower cost will be coming first. And finding the cost, adding the cost to the answer, and decrementing the count of how many times I can do the work with this cost. Then incrementing the new cost of the new guy which I've chosen. And after that, I just erase the key in case if it is 0. Basically, just implementation purpose. You can do it yourself also. Yeah, sorting a 2D vector is the same as sorting an array of pairs. Okay, so is this clear? Should we go ahead or do you have any doubts? Okay, fine. So let's move on. Let's move on to the next problem then. This is the third problem. Now you can read out the problem and then I will discuss. So I hope that you would have read the problem, like for the people watching on YouTube. The problem says that, yeah, I'm explaining the problem. So the problem says that there are n plus 1 slots. For every slot, you can just place a number between the range from 1 to m, sorry, 0 to m. You will be given three elements, n, k, and m. There are n plus 1 slots in which you can place elements from 0 to m, and you will be given one integer k. So we will come back to this later on. Like this would also be given, and m and k actually, in this order, m, k, and m, and m and k. So for every slot, you can just place any integer between the range 0 to m. And then what you have is you can choose any number for the n plus 1th slot. For the n plus 1th slot, you can choose any number between 0 to m. Yeah, basically, it was not for every slot, but just for the n plus 1th slot. And then for every element, it would go like this. that the nth number will have, or maybe you can say that a plus a of n, which is the number in the nth slot, will be equal to a of n plus 1 mod uh, n. For any general I, it would become a of I plus 1 mod I. This will be happening from the reverse order. Let me take an example. Let me take an example. So, so if you choose n plus 1 at 6, okay. So if you are having ns4, m equal to 6, and k equal to any number, we would be coming to this later on. Now, if you choose a of n plus 1, which is a of 5 as 6, if you choose a of 5 as 6, then a of 4 will become 6 mod 4, which will be 2. Then a of 3 will become 2 mod 3, which is again 2. A of 2 will become 2 mod 2, which is 0. A of 1 will become 0 mod 2, which is, sorry, 0 mod 1, which is 0. So one thing you could observe here is that at some point, 0 is definitely going to come. 0 is definitely going to come because at the end you are just modding it with 1. So even if the number is like any number, 0, 1, 2, any value, here you have at the end of the day, A1 would always be 0. Right. This is observation 1. Another observation is that at some point, like even before that, maybe we can skip it. Basically, the first time when it would become 0 is gonna be when this number, whatever number you have, is equal to a. So on that term, when you say कि जो भी whatever number it was modded by I, it would become 0. Or if it was a multiple of I, and the element k we had been given can be any number in the range from 1 to k plus 1, 1, 1 to n plus 1. And what we have to say, what we have to tell is how many ways are there for the slots, like for the values of slots, such that uh, there are k distinct values in the array. K distinct values in the array. This is what we have to tell. So let's take an example. If n was equal to 3 and m was equal to maybe 4 and k was equal to 2. So you could have m, basically you could have said a of n plus 1, which is a of 4, equal to, either you take 1 or you take 2. If you take 1, in that case, uh, you can try it yourself with what will happen for all the values. Basically, you will just get two distinct values. One of them will be 0 and other one will be the value you chose. You could have chosen 2, you could have chosen 3, but you could not choose 4. So there will be three distinct values you could choose for a of n plus 1. And whenever you choose any value for a of n plus 1, any value you choose, the all other values between a1 to an are not in your control. They are fixed. Right. Please tell me one thing. Did you understand this part? That whenever you choose a of n plus 1, any value for a of n plus 1, all the other values are fixed. Yeah. So you had only one, like you had only 0 to m. These were the only choices you had for a of n plus 1, and for all the other numbers, the choices are fixed. One thing you could observe here was that if you say a of n plus 1 equal to 0, all the values between this range would also be 0, because 0 mod any number is always going to be 0. So it would be one way, like it would have only one distinct value. So it would be one way of getting k equal to 1. In case if you place something like 1, 2, 3, any number till n minus 1, what will happen is that a of n plus 1, let's say you placed up 3 here. So a of n plus 1 equal to 3. A of n will be equal to a of n plus 1 mod n, which would be 3 mod n, which will be equal to 3 if n is greater than 3. For any ai where I is greater than c, a of I plus 1 mod I would also be 3 because I is greater than 3. But when I would be equal to 3 at some point, ai equal to a of I plus 1 mod 3 equal to 3 mod 3 will become 0. So it means that if you give some value between the range 1 to n minus 1, any value, there is some point it would remain the same as long as a of I is greater than the initial value you gave. After that, it would become equal at some point, right? Till some point it would be greater, then it will become equal, and when it becomes equal, it would become 0. And once it becomes 0, all the values smaller than that from a1 to a of I minus 1, it would remain to be 0 as a of I is 0. So from here, we could conclude one thing. If we want k equal to 2, we could just give it a value in the range from 1 to n minus 1. But there is one more thing, one more case. What if you have given a of n plus 1 equal to n? In that case, a of n will become equal to a of n plus 1 mod n, which is n mod n equal to 0. And once it becomes 0, you know that all the smaller values are also 0. So you have only two distinct values. So it is also a case for k equal to 2. If you had 2 into k, 2 into n, or 3 into n, or so on, till any value, let's say any number d, any integer d into n, which is less than equal to m. For all these values as well, there will be two distinct values, right? So in case if we are being asked for k equal to 1, we can definitely say one thing, that hey, only a of n plus 1 equal to 0 is the case where we can have it. So this is the answer will be just 1. We don't have any other choice. If you place anything else at some point, since it is going to become 0, it will get at least two distinct values. If you give any value in the range from 1 to n minus 1 and uh, m by n actually, like the number of multiples you have smaller than equal to m, uh, smaller than equal to m, all the multiples you have of n, all these values will also give you k equal to 2. So the answer will be equal to 1 plus n minus 1, sorry, the first n minus 1 numbers and m by n. Uh, you could think about it. And there is one catch in this. Like I'm telling you about all the observations at once. If you try out more and more, then you will be coming up to these cases randomly, or maybe you spend some more time. That what if m is smaller than n minus 1? What if m is smaller than n minus 1? In that case, you could have placed only those values from 1 to n. That could have been the only way, possibility for you. So here, instead of saying n minus 1, you can just say minimum of n minus 1 and m, and plus m minus m by n. In case if m is smaller, then it would just become 0, so it's not going to affect the answer. This is what you could say for k equal to 2. And You could observe one more thing here. Earlier, when we placed 0, we got k equal to 1, like just one distinct value. When you placed any number between this range from 1 to n minus 1, you got two distinct values. For all the multiples of n, for all the multiples of n, you also got two distinct values. And if you just pick up any other number, if you pick up any other number, let's say I pick up n plus 1, a of n will become equal to a of n plus 1 mod n, which would give you a value between 1 to n minus 1. It would give you a value between 1 and n minus 1, which would later become 0. है ना? As we saw in this case, how it was becoming 0. So the same thing will happen somewhere here. A of n would be in this range. So one distinct value you got was whatever value you chose for a of n plus 1, apart from the values which we discussed earlier, such that it is not a multiple and it is a value greater than 1. So this is one distinct value you got. This is the second distinct value you got since it was greater than n and it is less than n. So these are two distinct values. And 0 will be the third one at some point. This is how you could get for k equal to 3. And here you could notice this part also that it is never possible for you to get anything for k equal to 4 or any k is less than equal to 4. You can never have any like four distinct values or more. So you could say that for k is greater than equal to 4, the answer is straightforward 0 because it is never possible for you. And for k equal to 3, it is just in the range from 0 to m plus 1. Basically these m plus 1 elements which you could pick out of them, all the elements you got picked up in the k equal to 1 case. Let's denote it by k1. And all the elements you got in the case uh, k plus 2. So let's denote it by k2. These will be the values you can pick for getting three distinct values, and it would give your answer for k3. Let's denote it equal to k3. Now we can just say that depending upon the value of k, we have got the answer. Yeah, so it would look like this. You just took nm and k as inputs. Then we said that k for k equal to 1, like k1 is just 1. K2 is the equation we wrote earlier, that minimum of n minus 1 and m plus m by n. And K3 is m plus 1 minus K1 minus K2. And now depending upon the value of K, we can just give the output. And that's it. This is the problem. So is it clear? Okay, so let's move on to the next problem. This is the D problem. The D problem says that, like you can read it out and then I will explain it. Just pause and read it out. I hope you would have read it. So let's see the approach. The problem says that there is some n. We would be given some like an array of size n. N is the size of array, and you will be given an array of that size, which will have some values. I think it would be positive, but it doesn't really matter whether they are positive or negative. And from this, all the cells are initially white. You can choose some cell or whatever word they used, all the elements. So all the elements are white. You can choose some elements You can choose some elements. The indices are from 1 to n, 1 based indexing, and make them black. And make them black. After that, once you make them black, all the white cells whose which are multiple of like whose index or indices actually indices are multiples of at least one black cell, at least one black cell or element will become green. And now among all the black and green elements, among all the black and green elements, whatever element has the maximum value, whatever element has the maximum value, you just have to add its value to your answer. So just add its value to your answer, and um, you have to do this for all the for all the possible uh, white cells you could have chosen. So at this place, you could have chosen some white cells, and you had 2 into n minus 1 choices. For all these choices, 2 raised to the power n minus 1 is because you cannot choose like no empty cell, no white cell. You have to choose at least one, so that's why there is a minus 1. So it's like you had an array and you could choose some element. For every element, you had two choices, and that's how you got 2 into 2 raised to the power n choices. And one of them choices said that don't pick up any elements. So you that's why subtract 1 to get 2 raised to the power n minus 1 choices for picking up some white cells at the beginning and make them black. Now for uh, for all these, you know that the green cells which become are not in your hand. They will just become because it's a compulsion. You have just one choice for them. That's why you have like these 2 raised to the power n minus 1 ways. And now what we have to do is that for all these 2 raised to the power n minus 1 ways, whatever max element you are getting at the end, you have to find the sum of all these max elements. Sum of all these max elements. For that, the brute force way could have been to just backtrack and find it all for all the ways. Or the other way which I noticed was that for the array I have, in the array I have, if at any point I'm choosing I equal to 2, like the element at I equal to 2, then all its multiples would be also chosen because well, like they will either become green. They would become green. So it doesn't matter whether I choose them as black or not. They would become green for sure. So the max of these would at least be considered. है ना? In any case, if I choose this element. So what I did was to just say that for all a of I will just store the max of a of 2 into like a of 2 into a of 3 into and so on. I will just store the max of all of them at the same place. The reason is simple that in case if I do if I do like this, it is not going to make any effect for me. Basically, after that, it is not going to make any change in my answer at the end. As if I is equal to 2 is coming, so I equal to like a of 2i, a of 3i, a of 4i, all of them would come anyways. Now I will have another array such that this condition was holding for every AI. So the new array would be like this, which is where this condition is valid for all the i's. And now I just want to find the sum of max of all subsets of the array. Max of all subsets of the array. So now I just want to find the max of all the possible subsets of the array, which is a standard problem. It is a standard problem. So like not very standard, not very famous, but kind of standard. So you can just study about it on internet. Even if you write just this thing, sum of all subsets of sum of max of all subsets of the array, you will find articles to study about. Not study, but see the tutorial or articles about it. As a hint, what you would have done was something like sort the array in descending order or keep it in ascending order and start from the end, whatever. So just sort it in descending order. Sort it in descending order and then start from the left. Consider start in the start, just consider this one element. The element at the beginning, whatever it is, it would be the maximum. So there is just 2 raised to the power 0 uh, sub there is just 2 raised to the power 0 subsets which have it. Now when you consider the first two elements, or basically you can just see it in this way also, that for every element, if you are going to choose this, all these all the possible choices you have for remaining array, two choices for every element, which is basically 2 raised to the power 1 uh, choices. In all those subsets, this would be the maximum element. So you can just maintain a sum variable and add this here. That sum plus equal to 2 raised to the power n minus 1 into the current element into a of I, like this. And in this way, you will just find out the sum of max of all the sum of max of all subsets of the array. And just doing this will do the D problem. So the code looks like this. First of all, taking up all the inputs. And here I maintained it in one based indexing so that I don't have to again and again change from 0 based to 1 based. I just took it in 1 based directly. Then I applied this loop. Now, if you have, if you know the time complexity of this loop, where for every element, for every I, I'm just going to all its multiples, 2 into I, 3 into I, 4 into I, and so on. So for every I, the time complexity would be n by I, because I'm going till the multiples are less than equal to n. And if you just sum up n plus n by 2 plus n by 3 plus so on till n by n, this part comes to be log n. And the way is that you can just think of it in this way. For n by 3, like n just uh, it is something like just making this yeah, you can just assume it to be n by 2, like the sum of these values would definitely be less than equal to n plus n by 2 plus n by 2 plus n by 4 plus n by 4 plus n by 4 four times and so on. This is one way you can think of it. And at the end, you will have n plus clubbing up both of these to have n, then clubbing up these four to have n here, and so on till n log n times. So that's how it becomes n log n. And after that, I just sorted it uh, from the first because I'm having one based indexing, and then just calculated the sum. And here we had to return a modded value, so I was just doing the mod at every place as well. And it worked like this. So you can have any way of implementing it the way like this one as well. Uh, And is this clear? I think that for this part, you can just do it yourself in any way you want. And the part above will be similar for most of the people. Yeah, then let's move on. Now for the E problem, I could not do this during the contest. Like I came up with some approach, but I could not pass it. So I will be just telling you about the approach I had and the intuitions, like the observations I had. So um, what the problem says is that it will be given an integers, and at the start they are all uncircled. In one operation, what you can do in one operation, you can circle you can circle any number, even the numbers which are already circled. Uh, it includes all the numbers, like even the numbers which are already circled. And once you circle them, at the end in the array, you will be having some circled numbers and some uncircled. And you will be having some order in which you chose the indices to circle them. So let's call that order as P, like the array Pi is denoting the order. And all the elements which are yet uncircled, the values of all those elements, let's denote them by array R. Now we have to tell one way of choosing those elements such that array R and array P are equal. So both the arrays are equal. We have to tell one way. And in case if there is no way which does this, then we just have to print -1. Now one observation I had was that it was looking something like that in the array, if you have 3 here, then there is some relation between this number and this number. Let's say you are having 4 here, so there's some relation between these two numbers and so on. So graph was pretty intuitive. Right? Thinking about the problem like graph does make sense. Now, my focus was that how will I know for which element to give -1? For looking at this, I just look at the problem test cases and got one way that. By the way, for the graph, I said that for every node, I have some AI. For every index, I'm having some AI. So I would say that the ith node is pointing to AI. In this way, I imagined the graph. Obviously, I tried out multiple ways, but this one turned out to be making more sense. It seemed like this one makes more sense. So in the second test case we had, where we are just sorry, second test case, 3, 1, 2, 3. There are 3 elements, and every element is at its correct position right now. So you cannot remove any element. Let's say you remove the second element. You will have P in the array P, you will have a 2. But in the array R, you will never be able to have a 2 now. You can have 1 or 3, or if you remove any of these elements as well, then it would be removed from it. But this 2 can now to be at both the places at the same time. It is not possible. And in the graph which I saw was that it was having like all of them were having self loops. And now the thing is, even if these two values were something different, let's say 3, 2, 1, these 3 and 1 are not having any problem with each other. Like both of them can together do the stuff. You could have removed the 3, you could have removed this 3. So in the array R, you would have got 2, 1. And in the array P, you would have got uh, just 3. Sorry, just 1 because you removed from the index. So this 1 can be coming at both places, but this 2 is causing us trouble. And one better way of seeing this is that if you are having just 2 elements, 2 and 1, then you can remove the element 2. You will have 1 in the P. Array P you will have 1. And in array R, you will also have 1. So from this thing was coming up pretty like obvious to me that in case if I'm having a cycle of even size, like this was an intuition which I got, that if there is a cycle with even length, it is not problematic for me. But if there is a cycle with odd length or maybe self loops, it is problematic. So this was the intuition which I got. Here we are having some self loops, and then I came up with a case like this, where both the elements, like the node 1 and node 2, are having just values 2. So it becomes like if I want to keep this node 1, if I want to keep the node 1 in my R, I would have to remove, like, I must be having uh, the value 2. Basically, if I want to have value 2 in my R, the array R, I must have it in my P also, otherwise it is never possible. So I would be looking forward to remove the second node, which means that 1 is directing to 2, and the same thing goes for 2, like similar stuff. So we will have a self loop for the second node. And in this case, we are having a self loop, but what we can do is that just remove the second node. Just remove the second node. So removing this node will get you the node 1 going into the, like, being uncircled. This is uncircled for us. So the array R will have the value on the node 1, which is 2, and the other array will have, sorry, the array P will have the index which we remove, like basically the node number which was 2. So some kind of approach was coming that you can just use a graph. Every node I points to AI. If I get if I get an odd cycle, it looks suspicious. Like it looks like it won't work. I have not confirmed it since I have not submitted the problem till now, so I won't be very sure about this thing. But it looks like it won't happen. An odd cycle, it looks like it won't be submitted. It would not be submitted. Like it would not be possible. And for even cycles, it looks good. Now, one thing is, let's create this graph for the given input. This array, P4, 2 to 3. P4, 2, 2, 3. Here the nodes are 1, 2, 3, 4, 5. So the node 1 is pointing to node 3. The node 3 is pointing to node 2. The node 2 is pointing to node 4. And that node 4 is pointing back to node 2. And then we have this node 5 pointing to 3. Now, one observation here, like this is a claim or an observation, whatever you want to say, is that you have to keep you have to keep node 1 uncircled. Because if you want to circle on the node 1, how will you get it in R? Let's say if I circle this node, if I include this in my P, how will I go at the node 1 in the array? Like I don't have that value. So I won't be able to get it in R, which means that I must keep it as uh, uncircled. And if I'm keeping it as uncircled, if I'm keeping this thing as uncircled, it means that this 3 will be coming into my vector R, this array R. So I must be having this 3 in my array P as well, which makes one thing clear that I must remove this. So this directed edge is actually telling me that if you want to pick this one, you have to remove this 3. And the same thing goes for this 5. You don't have any other choice. You have to pick it, because if you don't pick it, like if you don't keep it in your uh, R, if you try to circle it, you would not have anything. Like if you circle it, you would not have any value of 5 in your P, or maybe the other way around. So basically, the this part is something you can even prove. Like this can be logically proved. Can be proved logically. Can be logically proved. Now from there, it looks like it is solvable. That I just start on with the nodes having no in degree, the nodes without any in degree. If I have a node with no in degree, I will just remove the node to which it points. All the nodes, like every node will have only one out degree. So I will just remove it. You know that in any component, in all the components which are being formed in your graph, there will be exactly one cycle. There will be exactly one cycle in all the components. This is something you should know, as there are n out degrees, like for n vertices, there is one out degree, exactly one out degree. And these are directed edges. So in this case, it always happens. It can also be logically proved. Now you just care about this part only, that what is the uh, length of the cycle. I guess this is the main thing which we have to see in the problem. I have not done after this part, like the part which I did after it was actually incorrect. And later on I realized it, but I have not submitted the part which I thought after it. So I think that I can end up the session at this place, since I don't want to pass on any information which I'm not sure about. Yeah. In case if you like the session, then please make sure to like the video and subscribe to the channel if you have not subscribed yet. And you can give your feedback from the pinned comment. Like you'll find the link to the feedback form in the pinned comment. And thank you for watching the video. Bye bye.